I came into this department with this background in large-scale atmospheric dynamics. How does the large-scale atmosphere organize itself? So one avenue of research is obviously to follow up on that and try to understand better, how these patterns work. Another avenue of research that I'm going into is trying to understand how the lower part of the atmosphere couples with the part of the atmosphere just above us, the stratosphere, where airplanes fly. And there's increasing evidence that the stratosphere is very useful for predictability and also for understanding climate change at Earth's surface. So that's one direction I'm going up in that sense. And then another direction I'm going is down, in the sense that I'm interested in how the ocean and the atmosphere couple with each other. So the way I look at climate is I look at large-scale climate variability in the observations. So what that means is I look at how the large-scale atmospheric circulation organizes itself. And these are patterns on the order of thousands of kilometers. So how does the large-scale atmosphere organize itself? And then how do these large-scale patterns, El Nino is one pattern you've probably heard of, although that involves the ocean as well. But and how do these patterns behave in time? And are they predictable? And how do they respond to anthropogenic, human-induced forcing, etc.? One thing that clearly interests me is the role of these patterns in recent climate change. So when people think climate change, you generally think global warming is what usually comes to mind. But there's an increasing resonance, certainly within the atmospheric science community, that climate change may very well be reflected as changes in how the atmosphere behaves. And so if we hammer the atmosphere with, say, changing the radiative forcing, say changing greenhouse gases, changing the amount of ozone we have in the stratosphere in certain places, then how does this then feed back onto these patterns, and how do they change, and then how does that impact our weather? And so one of the things I've done in the last few decades, along with other people, is, for example, interpreting recent northern hemisphere wintertime climate change. And so one of the primary conclusions that's coming out of mine and other people's work as well is that the prevailing notion that winters are less wintry in the last few decades, or the sense that temperatures have warmed over many of the mid-latitude continents, is as much a reflection of changes in the dynamics of these patterns as it is to global warming per se, or the changes in global mean temperatures. My work in the University of Washington was interpreting these large-scale patterns, and some patterns one pattern that I reinterpreted was this Arctic oscillation. These structures have now been identified, and the question is, why are they there in the first place? And also, to what extent a pattern such as the Arctic oscillation is really this large-scale structure that there's a million different ways of just defining it, but one way is that it's either a strengthening or weakening of the winds that encircle the polar cap at about 60 degrees latitude. And if you're to look at over the last 100 years how this pattern has evolved, is 1 month it's stronger, 1 month it's weaker. It's not regular, it's just noisy going back and forth. But in the last few decades, there's been this clear systematic bias in this towards stronger than normal winds around the northern pole, basically, at around 60 degrees north. What that means is that you have less of these extreme cold air outbreaks, for example.